So a particle moves in a straight line with the displacement from the origin given by this function, displacement equals 6t plus 5t squared. So firstly, we need to draw a motion graph representing the particle's movement for the first 5 seconds. So this is effectively a number line, and what we work out is the displacement for 1, 2, 3, 4, and 5 seconds. And in fact, there's one missing. We need to know our original position, s of 0. 6 times 0 plus 5 times 0 squared is 0. So we have a dot at t equals 0 over on the very start of the number line. From there, we've calculated S1, S2, S3, S4, S5, and we simply plot them on a number line. Now, some very important features. You need to include t equals 0, t equals 1, 2, 3, and so on. Without it, it doesn't make any sense. And it may very well be that the particle doubles back on itself, and so you need to be careful that you've labelled them correctly so we know exactly where the particle is at what time. So the average velocity for the time interval from t1 to t4, if we go back and have a look at the equation for average velocity, it's the displacement at the second time minus the displacement at the first time divided by the second time minus the first time. So if we substitute those values in, now how do we work out what those values are? So we've got 24 plus 80. That means all that is we've substituted the values in, so we equally could have just put 104. I've just substituted them into the equation. And 6 and 5 is 11. So they are just the position at time 4 and the position at time 1. And 4 minus 1 is 3, so that's 93 divided by 3, so 31 meters per second. So that means from the time, between the time 1 second and 4 seconds, the average velocity was 31 meters per second, which means it was travelling to the right. Because velocity is positive, that means it's travelling to the right. The instantaneous velocity at t equals 1 second. To find the instantaneous velocity, we need to find the derivative of our speed at t equals 1. So velocity is the derivative of speed, of displacement rather, which is 6 plus 10t. We sub in t equals 1 and we're left with 16 meters per second. So that means at the point t equals 1 second, the particle's velocity was 16 meters per second. Again, it's a positive velocity, which means the particle was moving to the right. And the acceleration function, we know that acceleration is the derivative of the velocity, which means it must be the second derivative of displacement. So all we do for that one is we find v dash of t. We worked out up here that v of t was 6 plus 10, so v dash of t is simply 10 meters per second. That's not printed properly. That should be second to the minus 2. And we know that that is our acceleration. So that's all it's asking for you there. So that means that this particle is accelerating at a constant rate of 10 meters per second squared. All right, that's enough to get you going on exercise 15E.1, questions 1 to 4. See you in class.